Good afternoon to all of you. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? I think we are live. So सबसे पहले बोलिए ना, do comment करके बोलिए. Is my audio videos clear to everybody? Is the audio videos clear to everybody? Do comment करके बोलिए. Right. Is the audio video is clear to everybody? Tell me first of all. Do comment करके बोलिए सभी ने. So चलो. Let's start our discussions, all of you. Yeah, सबसे पहले, so the great deal, it won't repeat. So try to utilize this opportunity before it going to expire. And this is a limited period offer. To enroll for it, you can use the code of BVReddy. BVReddy, and to avail this great opportunity and have a great learning experience for the top educators for 2027 के लिए. So this is just 9,999 only. Utilize this opportunity before going to expire. And another thing is All India mock test, which is on 18th of January. 2 slots are there at 9:30 a.m. and 2:30 p.m. The free mock test to all the students. With this All India mock test, you will get to know where you stand, how your preparation level and all. And the mega boot camp, which is running 12th to 16th January. So the test is on 17th January. So master your preparation in 5 power packed days. Attend the session and attempt the test. These are the ESC 2025 rankers from Unacademy. So the many more rankers you can have look at. And so the test series के लिए 2026 के लिए हमने बढ़िया से बढ़िया प्लान किया. You can have a look at now. The top educators team एक साथ आपको मिलेगा. And so we are starting a new batches. We are starting. You can have a look at now. So I'm you. So here the new batch. You can see this thing. To enroll for it, you can use the code of BVReddy and have a great learning experience. पर 2027 के लिए नया कोर्स लॉन्च होने वाला. You can see now for 2028 के लिए भी new course is going to start. Yes, Unacademy starter kit, which is available in all the stores. You can use it. And so West Bengal power sector vacancies has been released. So for this we launched the new course we have launched. You can have a look at now. Here the crash course, Kshetra batch, and another great feature of Unacademy is Unacademy Una. So with this you will get to know the great learning experience for the top educators team. You will get to know. At the same time, you will get to know these 3 modes of operations are there. One is voice mode, quiz mode, and smart summaries. And with this voice mode, you can have a look at. So here it will summarize all the content data. And the test series, which is live, you can have a look at. And Unacademy, we do offer the 2 subscriptions. One is a plus wala, other one is a iconic. Plus में आपको क्या चीज मिलेगा? Top educators classes, live doubt solving, evaluated mains test series, structured courses, PDF, live quiz, unlimited access. आइकॉनिक में इसके साथ you will get additional benefit of personal coach मिलेगा, ask a doubt and physical notes भी आपको मिलेगा. So right, so start your serious preparation with the Unacademy. We are there to provide you the best knowledge. Right, these are the GATE 2025 rankers from Unacademy. Yeah, do comment करके बोलिए ना भैया. So what's, अगर कोई डाउट हुआ तो tell me now. Any batch which is starting from 17 Jan, may you explain bit? So I am talking about this batch. Yes. So 17 Jan onwards we starting here. So new subject is launching, isn't it? चले. चलिए आज का सेशन हम शुरू करेगा. Right. So let's continue here. The last topics onwards will continue. We have discussed all these things. हमने last classes में हमने discuss किया all these things, and we'll continue the next topics. Right. Now let's talk about this one by one here. The electric field and potential for in case of different type of charges. And सबसे पहले we are talking about what charge here? Point charge we are talking. सबसे पहले we'll talk about the point charge. Tell me the point charge for electric field and potential for in case of a point charges. So that is the electric field E, and which is equal to what? Tell me now, vector. So that is KQ by R square into AR cap. The electric field for the point charges KQ by R square, and the potential V, which is equal to KQ by R. Potential V equal to what? Tell me, KQ by R. Right? Next, take one problem here. Three equal point charges located at the vertices of an equilateral triangle on the circumference of a circle of radius R. The electric field intensity and the potential at the center of the circle is. Yeah, you can tell me now here. They are saying here, right. So now three equal point charges located at the center of an equilateral triangle. They are located at the center, and the circumference here. So this radius, which is given as R. Now they ask him to find the electric field. They ask him to find. Yeah, you can tell me now here. So here we have one charge of plus Q. If I say this is one charge of plus Q, and this is one charge of plus Q. Yeah, you can see now here this distance. This is the radius now. Radius. Right. So this distance which is R, this is also R, this is also R. Right. So you can see now here the electric field we need to find. So here at this location due to the charge. So at the center they ask him to find now here electric field at the center which is equal to what you tell me now? The direction. It should be equal to like this. This is the electric field. If I call this is the charge 1, let us say this is the second charge and let us call this is the third charge. Next electric field here, this is this directions. And if I call this is E1 and this is E2 and this is E3. Okay. Now you can see now here. Now, so this E, so if you observe here carefully, now here, so this angle is 30 degrees. Now we can resolve into components. Right. So then this vertical angle. So this angle is how much you will become? So tell me now. This angle which is a 60 degrees. Alright. This angle which is also a 60 degrees. And so if you see this thing, the magnitude of all E1, E2, E3, these magnitudes are equal, isn't it? Magnitudes of E1, E2, E3 all are equal, which is equal to how much you tell me now? KQ by R square. And we need to talk about the directions very carefully. So, क्रिया हिंदी में ठीक है. सो हियर हम हिंदी एंड इंग्लिश दोनों लैंग्वेज यूज करेगा, कोई प्रॉब्लम नहीं है. ठीक है. सो नाउ वी कैन रिजॉल्व इनटू कंपोनेंट्स में रिजॉल्व करेगा. रिजॉल्व करो. यू टेल मी नाउ हियर दिस E1, इसका मैग्नीट्यूड तो सेम एज E1. सो इफ आई कॉल इसका पूरा मैग्नीट्यूड, लेट अस कॉल इट एज सिंपली E. So now this direction which is equal to E1. So now a component, what I can say now here, this direction. So this one, this component is what, tell me now here. We can say this as this direction. So this is E1 into cos 60. And so this direction which is equal to E2 also we can resolve now here. And this direction. And this is what we can say, tell me now here, E1 into sin 60. And this direction which is equal to what I can say, tell me now, that is E2 into sin 60. And this direction which we have E2 cos 60. So this E1 sin 60, this will E2 sin 60 will get cancelled. दोनों equal will get cancelled. And so if you see here, अगर आपने ध्यान से देखा तो here upward direction, this net electric field if you talk, and which is equal to E1 cos 60 plus E2 cos 60, these two are upward direction, minus E3 which is a downward directions. Then I can get it as E net which is equal to E1. E1, so it should be equal to E only in our cos 60 value 1 by 2 plus this is also E by 2 and that is minus E. So from this what I can get, you tell me now here, E net which is equal to 0. E net equal to 0. So that means net electric field is how much? 0. And what about the potential? You tell me now. Potential V, which is equal to what? Tell me now here. Potential is a scalar quantity. So that means potential due to three charges we need to find. So which is given as V1 plus V2 plus V3. So that is V, which is given as, that is KQ by R plus KQ by R plus KQ by R. Potential is a scalar quantity, so here no need to talk about the directions. The only magnitude is important. So it should be given as what I can say, 3KQ by R. So potential अगर आपने ध्यान से देखा तो potential तो maximum आई. Potential is maximum, but electric field is 0. Electric field, not only this thing, electric field at the center of any regular bodies which is always 0. Right? अगर आपने consider किया तो square equal sides, all the corners, if we play the equal charge we place now here. What is the electric field at the center? We can say electric field at the center. What is the net electric field? You tell me now, which is 0. Okay. And equilateral triangle, what is the electric field? The centroid, which is equal to, that is also 0. Hexagon, yes, that is also 0. Electric field at the center of any regular figure, which is always 0. Electric field at the center of any regular figure, which is always 0. But magnetic field cannot not be 0. And we'll get to know how much will be the magnetic field when you're discussing a magnetic field chapter. Right? Next. So electric field due to line charges. For the line charge, electric field E, and which is given as 2K lambda by R. Electric field due to line charge is given as 2K lambda by R, and direction is AR cap. And direction is AR cap. So where K is what? I'll be 1 by 4 pi epsilon naught. K means what? 1 by 4 pi epsilon naught. And that is, if the medium is a air, so that is 9 into 10 power 9. Okay. Next, lambda is what? Tell me now, line charge density. Lambda is a line charge density. And with the units of coulombs per meter. Okay. Next. Now you can see now here. From Gauss law only we got it. Yes, from Gauss law only. So here this is the crash course now. So here the derivations is not possible to do it now. I'm focusing on the problems and some formulas only I'm focusing here. Yes, digital ka PDFs I told you now. So here I given this thing here in the Telegram. So you can do message me BV Reddy sir. You will get the you message me. I will share it. So you can message me here. So you will get it now. So this is a Telegram mein message karo either. So then you will get the PDF. Complete notes, all the PDF, short notes, everything available there. You message me in the Telegram. Right. So you can see now here a infinite line uniform charge density given. So that is lambda charge density lambda, which is given as what element 20 nano coulombs per meter they given. So it lies at x is equal to 2 to x is equal to 4. Now it lies at where you tell me now on this x-axis, and here this is the origin. If I call here, this is x is equal to 2 and this is x is equal to 4. Where it will lies, you can see now here at x is equal to 2 to x is equal to 4. X is equal to 2 to x is equal to 4, and there is a line charge is there. We need to find the electric field at the origin. We need to find. Okay. Now you can see now here to do it now here. So in this case, the formula what we have seen previously, that formula applicable for in case of line infinite line charge. But here they given finite line charge now. Then what you need to do here in this case is, if it is a finite line charge, and we will do it as, we'll simplify it as like this. We'll take a small strip I have taken, and this small strip, this length which we can call it as a dx, and the dx which is at a distance of what I can say x from the origin. So now I'm finding the small part. We have some charges there now. The charge I'm calling it as a dq. So can we find the electric field because of the small charge? That is, we are calling that electric field is a dE, which is given as what element of here k into, that is dq by, which is at a distance of what element of x square. Now what is this dq, you tell me now here? That is given as lambda into dx. And this lambda value which is given at 20 into dx. Lambda given, that is 20 into dx. Now we'll simplify now here. So that means what is this dE value, tell me now? So this is 20 k20 dx by x square. So what is this E value, tell me now here? Which is equal to 20k, which is a constant. Now integration of what element of dx by x square. The limits are what element of x is equal to 2 to 4. So from this we can get this electric field as 20k. 20 is a 10 power minus 9 and x square integration minus 1 by x. Limits are 2 to 4. So then E will come to be at 20. K value is what, tell me now here? That is 9 into 10 power 9 into 10 power minus 9. And this is minus will come here. And we can place now 1 by 4 minus 1 by 2. Now simplify it now here. Minus 9 plus 9 will get cancelled. So that is E is equal to, so this is minus 180 and this is LCM. So this is 2 minus 4. This value 4 is LCM now. 1 minus 2 by this is 4 is LCM. So how much will come this E value, tell me now? So which is equal to 1. So this is 180 into what element of here? 1 by 4. So then 2's and this is 90. So then E value how much now here? 45 na? 45 volt per meter. Check करके बोलिए now. All of you got the same thing or not? This is X. This is a finite. Okay, correct. Done. Now you can see now here an infinite long uniform charge density 30 nanocoulombs per meter is located at y is equal to 3 comma z is equal to 5. The field intensity at 0 comma 6 comma 1 is given. They are asking to find the electric field intensity at 5 comma 6 comma 1 is. Okay. Now you can see now here. And so this is here they given this infinite charge. Okay. Now you tell me now charge which is placed along what direction you see this thing? Y is equal to 3, Z is equal to 5. That means X can be anything. So which is placed now here? Y value 3 given, Z value 5. So that means which is parallel to what axis? We can say X axis. So this is parallel to X axis. Now we'll find this electric field now here. What the electric field formula you tell me now here? That is given as 2k lambda by r into AR. Here R value we need to calculate now. What is this R value? Tell me now. Vector form we can find. So we need to find the electric field where you tell me at 0 comma 6 comma 1 we need to find. Due to what charge now? This is the charge which is given as X value 0 and Y value 3, Z value 5. So the line charge is parallel to what axis? Line charge parallel to what axis? X axis. Parallel to X axis. That's why. Now you can see now here what I'll get this R bar value. Tell me now here. So this we can say now 3 into AY minus 4 into AZ. Okay, this thing. And due to this electric field which is given as we'll get now here. So this value 2k q by this one. So this will get now this electric field they given as E value given as how much you tell me now? 64.7 into AY minus 86.3 into AZ. This is electric field, right? Next. Now they given the new point is what? Tell me now here. If I call this is the R1. And what the second point they given you? Tell me now R2 bar which is equal to what? Tell me now. Other point 5 comma 6 comma 1 2 where due to what charge now here? Parallel to X axis. So X coordinate remains same. Y value 3, Z value 5. So then R2 bar which is equal to 5 minus 5 0 6 minus 3 that is 3 into AY minus 4 into AZ. Here you see this thing here R value same now. So what will be the electric field now here? This E2 which is also same as E only. The value, so the K value same. Here 2 constant K same. Here lambda also same. So here the magnitude of R is same now. What is the modulus of R if you see which is equal to 5. Here also modulus of R is what element of 5 only now. And the direction is also same only. Isn't it? So that means what is the electric field at the second point you tell me now here which is equal to Now, so that is given as 64.7 into AY minus 86.3 into AZ, right? And here the line charge, which is here, basically you can observe here, the line charge is parallel to what axis you see? The line charge is parallel to x-axis. The line charge is parallel to what axis? X-axis. If the line charge is parallel to x-axis, now the electric field, it does not depends upon the x coordinate. It does not depends upon what? Tell me now here, x coordinate. Here you see, now here first point they given as what? Tell me now, 0, 6, 1. So this, since the line charge parallel to x-axis, it does not depends upon this x value. Second point is given as 5, 6, 1. So it does not depends upon x coordinate. So you can see now y and z values are same only now. So that's why electric field is also same. Understood what I am saying here? So that's what we have the conclusion. You see this thing here. If the line charge is placed parallel to any of the axes, then the magnitude of electric field is independent of the corresponding coordinate. Independent of the corresponding coordinate, and the component of electric field along the direction of line charge is 0. Component of electric field along the direction of the direction of the line charge is 0. That's it, isn't it? Next, circular ring charge. Consider this is my circle, and which is having this radius which is equal to A, and so this will have a charge density, I am calling it as a lambda, and the total charge of this part, if I call it as a Q, so we can define the line charge density lambda, which is given as 2 by 2 pi A, and with the units of what element of coulombs per meter. Coulombs per meter. Due to this line charge, we are finding the electric field we are finding. Okay. Now, so if we consider this line charge like this, consider now this one. So at this point, we need to find this point is P. And here we are calling it as what? Tell me now here. This is the radius. Radius I am calling it as A we have taken. This distance let us call it as X. And so from this one, so this distance is what? Tell me now here, square root of, that is A square plus X square. A square plus X square. Now, so we need to find this one, the electric field at this point, because of this line charge. The electric field which is given as E. So I am not focusing on the derivations. So let's try to understand the formula, and based upon the formula we'll learn how to apply this formula to solve the problems, and which is given as, right. So this is in terms of, if we write it as a Q, so which is given as KQ X by a square plus x square power 3 by 2. And the direction which is radially outward. This is the direction of electric field. If I say this is x-axis, so then this is Ax cap. KQx by a square plus x square power 3 by 2. Where x is what element of distance from center to the point P. This distance is x. Right. Now, if I want this electric field at the center, then x value will becomes what element of 0. X value 0, then what is this electric field? You tell me now here 0. At the center of the ring, electric field is how much? 0. Now at the center is 0, I want to know where this electric field is maximum. And so then how we can get the maximum value of any function? We can get the maximum value of any function by differentiate and by equating to 0. So for this, to get this maximum value, what I should do here? So differentiate this electric field with respect to x and will equate it to 0. Then by simplifying this thing, x value will come to be a plus or minus a by root 2. Simplify, you will get it as x value is plus or minus a by root 2. This is very, very important. Try to remember. So where this electric field is maximum, at x is equal to plus or minus a by root 2. Electric field is maximum. Where a is a radius. Okay. Next. So let's talk about in case of an arc. Electric field intensity due to a circular arc. Circular arc, consider we have the circular arc is like this. Circular arc which is like this. This angle theta, this radius I am calling it as arc. The electric field at the center, at the point, this point here, at this point we need the electric field. This electric field E, which is equal to what tell me now? KQ by R square into sine theta by 2 by theta by 2. KQ by R square into sine theta by 2 by theta by 2. Okay. So now where theta is the angle. So you can see now here for in case of a quarter circle. For the quarter circle, how much is electric field you tell me now here? For quarter circle, अगर आपने ध्यान से देखा तो how much the theta value which is equal to quarter circle pi by 2 na? Pi by 2. So for pi by 2 now substitute the value of theta here, which will come to be a what element of KQ by R square into what element of sine theta by 2. Sine 45, that is 1 by root 2 by pi by 4. So you can tell me now how much will come. So this value. So 4 will go to here, that is 2 root 2. 2 root 2. 2 root 2 by pi. Yes, 2 root 2 by pi into what will get now here? KQ by R square. And semicircle, how much the theta value? Tell me now here, theta value pi. Semicircle. So then how much this electric field will come? You tell me now. That is KQ by r square into sine 90 1 by 2. So that means what we can say, and then pi by 2. So that means E value will come to be a what, tell me now here, that is 2 by pi kq by r square. Next, circle, theta value how much you tell me now, 2 pi. So then how much is electric field circle के लिए अभी ने हमने देखा, so this value तो it is 0. Electric field at the center of a circle is how much? Always 0. Right? Next. Now you can see now here, a circular ring of radius r having a charge distribution rho L. That means line charge density. It is placed in xy plane such that its axis coincide with the z axis. Okay. The point on z axis where the electric field intensity is maximum. Abhi ne dekha na, where it will be maximum? Yes, at radius given now. So that means plus or minus, what I can say, tell me now, r by root 2. At plus or minus r by root 2, electric field is maximum on z axis now. So that means z coordinate. So 0 comma 0 comma plus or minus r by root 2. Right? Next. A ring of charge is placed. They given y square plus z square equal to 4. X is equal to 0. So what is this plane, you can say, tell me. And so what is this plane, you tell me now. This plane which is a xy plane. So z is equal to 0 plane now. So this is yz plane. So this is, which plane is a yz plane. Yz plane, x value 0. So x is normal. So they are asking to find the electric field at where, you tell me now here. Electric flux density. D they are asking to find. E value we have seen now. E value which is equal to what, tell me. That is kq x by a square plus x square power 3 by 2. Okay, so this radius, they given y square plus z square which is equal to 2 square now. Here the radius, a value how much now? 2. So line charge given now, so this means lambda given as how much? 5 microcoulombs per meters. That means q is equal to what I can say now here, lambda into 2 pi a. So that is lambda, q is equal to lambda value 5 into 10 power minus 6 into 2 pi a. A is what value, tell me now here, 2. So then q value will come to be what, tell me now, 20 pi na? Yes, 20 pi into 10 power minus 6 coulombs. Okay. Now we can substitute these values. So E value. Okay, so and so from this E is equal to 1 by 4 pi epsilon naught qx by a square plus x square power 3 by 2. Now they are asking D na, D is equal to epsilon naught E. So from this will come it as 1 by 4 pi, that is qx by a square plus x square power 3 by 2. Yeah, simplify it now. What will get now here? 1 by 4 pi. Q value how much now here? 20 pi into 10 power minus 6. X value, yes, 3 by a square means 4 square. No, 4. 4 plus A square minus x square. This is 9 whole power 3 by 2. Yeah, do simplify, get the answer. You can simplify it now. Simplification will take some more time. So you will calculate this thing. So do verify, you will get this as 9.03 into 10 power minus 7 will come. Coulomb per meter square. Direction is AX cap. AX cap. Coulomb per meter square. Check this value. Next. Two charged rings, each of radius capital R, with charges Q1, Q2 are placed parallel with separation x between the centers. Find the electric field and potential at the center of the rings. Right. Now C means what they given now here, two charges. If I call this is the z-axis. If I call this is the z-axis, the two rings are separated by parallel to each other. Here we have a one ring and here we have the another ring. Placed parallel with separation x between the centers. Find the electric field and potential. Find the electric field and potential at the center of the rings. So if we call this point, if I call this point is A and this point is B. Okay. Both having the radius. This radius is R, this radius is also R. Having the charge, if I say Q1, the charge is Q2. Okay, and separation between the centers. This separation between these two, the distance which is given as something x they are calling. They are asking to find the electric field and potential at the centers. Now let us find at point A, at point B, both we need to find. Yeah, you tell me now here, this is electric field at point A, which is given as what I can say. So electric field at point A, because of the charge, electric field which is equal to 0. Okay. Next, same charge now. Now we need to find the electric field at the point A because of the second charge. So how much the distance you see this thing, x distance. So what I can say now, K, Q is Q2, x by, what we can say now here, radius which is r, so that is r square plus x square power 3 by 2. R square plus x square power 3 by 2, isn't it? And what is the potential at point A? Tell me. Potential at point A. Potential at the point A is because of this charge Q1 as well as Q2. Potential at point A, which is given as what? Tell me now. K Q1 by R plus second charge, that is what? Tell me now. K, this is Q2 by, how much the distance you see this thing here, that is given as root of r square plus x square. Understood? Next, let's do this as second one here, EB. Electric field at point B, and which is equal to what? Tell me. Electric field at point B. So because of this first charge, which is given as K Q1x by, that is what? Tell me now here, r square plus x square power 3 by 2 plus, because of its own charge, 0. Next, what is the potential? You tell me now. and which is given as, what will get now here, K, that is Q2. First we will find the Q1. K Q1 by root of R square plus X square plus K Q2 by R. See this thing, all of you? Next, electric field due to a surface charge. Surface charge, this is a non-conducting surface charge. Now, so this we have given us some charge of Q is given. This area which is equal to something A. Then we can define the sigma, surface charge density, which is given as, what we can say now, Q by its area, surface area, with the units of coulombs per meter square. Now the electric field due to surface charge, which is given as, for in case of non-conductor, so which is given as sigma by 2 epsilon naught into the direction is En cap, normal directions. And what this En cap is a? En cap is a unit normal vector. En cap is a unit normal vector. En cap is a unit normal vector. So this En cap, so it may be a positive, may be a negative. It is positive if the point lies above the surface charge. Above the surface charge. And if this En cap, which is equal to what, tell me now here, negative, if the point lies below the surface charge. Okay. Next, if it is a conductor, this electric field to be a conductor which is equal to what, tell me, that is rho s by epsilon naught, and the direction which is given as En cap. If it is a non-conductor, by 2, for conductor only epsilon naught only. Okay. So in the problem, they don't mention whether it is a conductor or non-conductor. You can treat it as a non-conductor only. If they mention, then only consider, otherwise take it as a non-conductor. Now, and you can see now here, two infinite states having charge densities are given. They are asked to find the electric field. Where you tell me now here? Above and below, and in between they ask to find. So if we consider, so this is x-axis. If I say this is x-axis, now we have the two surface charges lies. One is at x is equal to 0. So that means I can say this one One is at x is equal to 0. X is equal to 0, we have a charge. So let us call this is the sigma 1 if I call, which is equal to how much now here? 10 nanocoulombs per meter square. The second one is at x is equal to 10. The second one is at x is equal to 10. So this is at x is equal to 10. And this is sigma 2 if I call, which is equal to how much now here? Minus 10 nanocoulombs per meter square. Now, due to this, we need to find the electric field where now here? Above the two sheets, means let us call this point. If I call this point is A. Next, below the two now here B, and in between let us say C. With 3 points we need to find. Now you can see now first one, what I can say now here, electric field at point A, and which is equal to what, tell me? So electric field, because of the, you are calling this is the charge 1 and this is the second charge. So which is given as electric field into charge 1 plus electric field into second charge. Okay. So tell me now electric field into first charge, that is EA, which is given as surface charge. Now electric field formula is what, tell me now here? That is sigma 1 by 2 epsilon naught. And the direction is what, tell me now here? Yes, above positive x direction now. So we can say this as plus ax cap and plus sigma 2. That is sigma 2 by 2 epsilon naught into this is also ax cap only na. So from this we can get it as EA as what, tell me now here? Sigma, this is what we have, 10 by 2 epsilon naught into ax cap minus 10 by 2 epsilon naught into ax cap. So then how much this value, tell me now here? EA value, which is equal to 0. So that means electric field, which is 0. Next, find the electric field below the two charges. Now second point, that means at the point B, which I will call it as same thing here, E1 plus E2. So you can tell me now here, what is this thing? EB value, which is equal to E1, which is equal to what, tell me now? Below na. So we can say this as 10. So 10 by 2 epsilon naught into ax cap. So this is minus na, minus ax cap below minus 10 by 2 epsilon naught into this is charge. The point B lies below the second charge also. That's why it is minus ax cap. So what I will get, you tell me now here? EB value, this is minus 10 by 2 epsilon naught into ax plus 10 by 2 epsilon naught into ax cap. Right. So that means how much is net electric field, you tell me now? And which is equal to 0. Right. Now we need to find in between also. Tell me now in between what I will get, you tell me? Tell me now in between C. In between, that is EC, which is equal to what, tell me now here? E1 plus E2. So that is given as EC, which is equal to E1 So that is 10 by 2 epsilon naught. For this one, so for the charge one, point C lies above. That means we can say this as plus Ax cap. And this is my plus minus 10 by 2 epsilon naught. And for the second charge, the point C lies below. That's why it is minus Ax cap. So that means how much this value will come? You see this thing here finally. The total electric field EC, which will becomes what, tell me now? 20 by 2 epsilon naught into Ax cap. Okay. So this electric field in between which is added. Above is 0, below is also 0, in between only which is non-zero. Right. So you can see now here three charges are there. Three charges. They are placed at respective location they have placed. Now they are asking to find what, tell me now here. The electric field at this corresponding location they are asking to find. Now first charge, where the first charge has been located, you see. First one, so this is x is equal to fourth plane. And how much the charge, you tell me now, sigma 1 if I call, which is equal to 18 nanocoulombs per meter square. And second one, y is equal to minus 3 plane. Surface charges na, that is sigma 2, which is equal to 9 nanocoulombs per meter square. Next, z is equal to minus 24 nanocoulombs per meter square. Then sigma 3, which is equal to what, tell me now? Sorry, z is equal to 0 na? Z is equal to 0. So this value minus 24 nanocoulombs per meter square. Now they are asking to find what, tell me now here? The charges. Yes. Now we need to find this electric field at a given point. This point is given as 806. So you tell me now electric field which is given as electric field into charge 1 plus electric field into second plus electric field into third charge. So that is E, which is given as E1, which is equal to what, tell me now here? Sigma 1 by 2 epsilon naught. And so this we need to find at x value 8. Here x value 4. Above only now. So means what I can say now here? Plus Ax cap. Next plus sigma 2 by 2 epsilon naught into this is x value 0 means above only. So that means plus Ay cap plus, so what I can say now, sigma 3 by 2 epsilon naught into, so this is also above only. So this is Az cap. So now you can place now here one by one. Sigma 1, how much is value? 18 by 2 epsilon naught into Ax cap. Sigma 2, that is 9 plus 9 by 2 epsilon naught into Ay cap. Now sigma 3, that is minus 24 by 2 epsilon naught into Az cap. right? Next. Now spherical volume charge. Spherical volume charge. Now let's talk about the spherical volume charge now here. So in these cases, we are going to talk about the hollow sphere, solid sphere both. Hollow also we have two cases, and so conducting, non-conducting. Now first we are going to talk about what tell me now here, solid conducting sphere. Next, hollow conducting sphere and hollow non-conducting sphere. All these three will come under the same category. Okay, solid conductor, hollow conductor, hollow non-conducting. All these are comes under same categories. So the formula is also same for these cases. Now consider we have the solid conductor as hollow conductor and the hollow non-conductor. All these cases are same only. And we have, let us consider the radius which is equal to capital R. And the solid conductor will have charge lies only on the surface only. There is no charge lies inside. The net charge inside is 0. Okay. So let us find the electric field now here. So what is this electric field you can see now here? So this electric field E, which is equal to what will be now 0, where this is for 0 less than R less than capital R. Up to the surface now electric field is 0, and electric field will lies only on the surface only. That is given as KQ by R square. And of course direction means AR directions, radial direction, and this is for R greater than or equal to capital R. Okay, this one. And potential which is equal to, potential also important, potential at any point inside the potential is constant, that is given as KQ by capital R, that is for 0 less than small r less than or equal to capital R. And so outside which is equal to KQ by small r, if the small r is greater than capital R. Outside. Inside you see the potential remains constant. Outside potential decreases. If we draw a graph, the variation of potential with respect to distance, how we have a graph, you see? The graph is like this. Now this is R and this is E. Now this is at R equal to 0. Now you can see now here up to small r equal to 0. So this one electric field is completely 0. Yes, so up to here small r equal to capital R. And thereafter electric field reaches to high value surface, and after that again which will decreases non-linearly. Here which is the electric field is maximum, that is KQ by R square. Now here, how much this electric field, you see this thing, which is equal to 0. Next, and if you draw this potential graph, how this graph you can see now? Potential on the surface, which is remains constant. And thereafter decreases non-linearly. And this is small r equal to capital R. And this is given as KQ by R. And this is the potential V, and this is R. So here this electric field, which is proportional to 1 by R square. Here potential V is a constant, and here in this region potential proportional to 1 by R. These graphs are very important, so try to remember. Next, now we'll talk about the solid non-conducting sphere. For in case solid non-conducting sphere, how this potential will varies. Solid and non-conducting sphere. So this means the radius is capital R. Since it is a solid non-conductor, charges lies inside also. Charge will lies inside also will lies. Okay. Now we'll find this, that having a charge is Q. We'll find this electric field inside as well as outside will find. So this electric field inside will calculate. And which is given as KQR by RQ. And this is the electric field inside. 0 less than R less than capital R. And that is equal to outside is KQ by R square into AR. This is for small r greater than capital R. Okay. Small r greater than capital R. Right. So if you draw this graph, can you tell me now how this graph may come? So inside, how this variation you see? This is electric field R equal to 0 to R. So here inside, which is a straight line passing to the origin, increases linearly up to where you can see now here, up to small r equal to capital R. And thereafter what happens now here, which will decreases non-linearly. Which will decrease non-linearly like this. And whatever the potential, tell me now potential V, which is equal to KQ by So this is potential outside, inside, which is given as KQ by R square, sorry, KQ by R into, we'll get this as 3 by 2 minus R squared by 2R. So you can see now potential when this is the potential for where you tell me now here 0 less than R less than capital R, and outside which is equal to simply KQ by capital R, and this is for what tell me now R greater than capital R. Now you tell me now here at R equal to 0, that means the center, means at the center, means what happens now here. So potential, how much this value tell me now, V potential at the center, which will come to be a KQ by R into 3 by 2. Okay, now potential on the surface. On the surface means what tell me now, small r equal to capital R. So which is given as Vs on the surface, small r equal to capital R square. Okay, small r equal to capital R, then it will becomes what tell me now here, that is K Q by R, isn't it? Check it on the surface, KQ by R will come. Now you can see now this one, a 1 nanocoulombs point charge is placed at 0, 2, 0. Potential at 0, 4, 0 with respect to at 0, 8, 0 they are asking to find. Right. So potential we need to find where the charge has been located, 1 nanocoulombs of charge which is located at 0, 2, 0. At a point, if I call this point is A, and so this location of this C is given as 0, 4, 0. Next point which is given as B, which is given as 0, 8, 0. Right, so this means which I call it as RA, and this is call it as what I'll be now RB. Right. Now you can see now here RA potential at this point. So we need the potential at A with respect to B. That means VA minus VB, which is given as what I'll be now KQ by RA minus what I'll be now KQ by RB. So which could be given as what we can say now here, KQ, K value that is 9 into 10 power 9 into a charge which is equal 10 power minus 9 into 1 by RA. RA value how much now distance, that is 1 by 2. Yes, minus that is 1 by 6. Now simplify now here, potential at A with respect to point B, which will come to be a, this is 9 into how much will come here? 6 is the LCM na? So this is 3 minus 1, and that is given as VA minus VB, and which is equal to 9 by 6 into 2. 2 threes, 3 threes. So this means how much you tell me now here? 3. Right. Now see this problem, they given the potential, they ask him to find the electric field. And what is the relation between electric field and potential? You see, electric field and potential, the relation which is given as what? Tell me now. E equal to minus del V. E equal to minus del V. So that is E, which is equal to minus of what we'll get now? Del V gradient na? So here V value given as what? Tell me now here. X minus Y plus XY plus 2Z. Now, so here find out now here del V. So this is minus of. So x derivative will come it as what? Tell me now here. 1 plus y into I cap plus y derivative. This is minus 1 plus x into j cap plus 2 into k cap. So from this, what I will get? You tell me now. E equal to, this is minus of the point which is given as 1, 2, 3. Substitute this point now here. 2. So 2 plus 1, which is equal to 3i. And x value 1, so it will become 0. So that is 0. Next plus 2k. So this thing. Next. So see this thing, let E value given, they ask you to find del dot E volume integration, they ask him to find. So E value given as what? Tell me. That is 2x square into I cap plus 5y into j cap plus 3z into k cap. So let us find the del dot E divergence. X derivative will come it as 4x and y derivative will come it as 5 and z derivative will come it as 3. So this means how much will come here? 4x plus 8. Now we need to find what? Tell me now here. This is volume integration of del dot E into dV, and which is equal to. So you can see now here. So this is volume integral. So x limits are what? Tell me now. 0 to 1. Y limits are what? Tell me now. 0 to 1. And z limits are what? Tell me now. 0 to 1. So we'll come it as what? Tell me now here. 4x plus 8 into dx, dy and dz. Now you can see now here. here this variation x, y, z, all the limits are 1, 1, 1 only. So this means 4 into, so x integration will come it as what I'll be now x square by 2. Y integration, so this is y and z plus 8 into what I'll be now x, y, z. So the limits we can substitute now here. This is 2. X is 1, y is 1, z is 1. So this value 1 plus 8 into this is 1. So which will come to be a what I'll be now here 10. Next one. And take this problem. The electrostatic, the electric displacement density given, the D value given. So they ask him to find what, tell me here. A cubical region centered at the origin with each side of length 1 meters and vertices given as plus 0.5 to minus 0.5. Now, so this flux, what is the flux now according to Gauss law, which is given as what I'll be now here closed surface integral of d bar dot ds, and that is also equal to what I'll be now volume integration of rho v into dv. Yes. Now, so here they given directly, they given as flux, they ask into electric, that is equal to charge only now. Now, first what I can do here, Q is equal to, and del dot D, which is equal to rho V. So first we can find this rho V value. How much now? Del dot D, divergence now here will come x derivative, so that is 3x square plus 3y square. That's it. Now, so that is Q is given as what tell me now here volume integration of, so this is rho v into dv. So this means integrations, and here you see this thing, of course this is the even function only now, so we can write as, so this term we can write it as x integration, x limits are what will be now minus 0.5 to plus 0.5. Next, y limits are minus 0.5 to plus 0.5, and z limits are minus 0.5 to plus 0.5 into what we have, tell me now here, that is 3 into x square plus y square into dx, dy and dz. So you can tell me now here, so that is Q is equal to, yeah, tell me now here. Now I can say these terms, if we split these limits also, now, so this value x limits are minus 0.5 to plus 0.5, and y limits are minus 0.5 to plus 0.5, and z limits are minus 0.5 to plus 0.5, that is 3x square into dx, dy, dz plus, so this means x limits are here also minus 0.5 to plus 0.5, and y limits are minus 0.5 to plus 0.5, and z limits are minus 0.5 to plus 0.5. So we have 3y square dx dy dz. So you can apply this as an even property now. What I can say now here, so since it is an even, will come it as 2 into, this is 2 into 2 will come, as we can write it as, what tell me now here, x integration, you tell me now, this is 3 into x cube by 3 now. And this limits are what we can say minus 0.5 to plus 0.5. And y integration y only, so will come it as 1, z integration 1 plus, so this is 3y square by y cube by 3, limits are 0.5 to minus 0.5 to plus 0.5, this is 1 1 only. So you can simplify, how much will come? Simplify this value, 3 will get cancelled, 3 will get cancelled, this is 1 only. So we can have it as, what tell me now here, so this is 2 into 0.5 whole cube plus 2 into 0.5 whole cube. Check करके बोलिए what will come. 2 plus 2 4, so that is 1 by 2 will come. Check it all of you. La, 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 la. An infinite number of concentric rings carry the charges alternately positive and negative charges. They ask him to find what element of potential they ask him to find. Now you can see now potential V. Potential V equal to what we can say? KQ by R. V. So V is equal to what element of KQ by R. So you can see now distances now here V. Now which is equal to what I'll get to tell me now here, KQ by R, which is equal to 1. Yes, minus plus minus alternative now. So that's why KQ by 2 plus KQ by 4 minus KQ by 8. Like this will continue. So V, which is given as KQ, we have taken common, then it is 1 minus 1 by 2 plus 1 by 2 square. Okay, that is minus 1 by 2 cube plus, like this will continue now infinite that. So that means V, which I can say this as KQ by geometric progression, that is A by 1 minus R na 1 by 2 plus minus or minus plus. So will come it as 2KQ by 3. K value, so this is 2 by 3 into K means 1 by 4 pi epsilon naught into Q na. So these two 2's, so will come 6. So that means Q by 6 pi epsilon naught. La 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 la. So let E is the electric field and V is the potential. V given, see the option they ask him to find. And directly we can say del dot V not possible now. So this is good, wrong. So this is always true only, divergence. This one, gradient of divergence. So this value, okay, we can't say directly, we need to verify. del dot V divergence cannot be defined for in case of a scalar quantities. So this is also wrong. V is a scalar now. Divergence is not defined for scalar quantity. Only for vector only it is defined, right? So that's why that is also wrong only. And so let's find the E. Now here the relation between E and V. E is equal to what element of minus del V. E is equal to minus del V. So that means we can find out now here minus of gradient. So this x derivative will come it as 1 into this is I cap plus j cap plus k cap. So this means mod E which is equal to root 3. So first one is correct only. This is correct. Yeah, this is also correct only. So if we find the divergence of this E, del dot of del V. Del V we got now. So this value, if I differentiate now here, this is del dot of E, which is equal to how much now this derivative divergence is 0. So only 1 and 2 are correct. La 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 la. Like this. Fine. Next, Poisson's equation and Laplace equations. And Poisson's equation, what we have this as Maxwell's first equation we have, that is del dot D, which is equal to rho V. We know that D is equal to what element of here, epsilon naught E. From this we can say this is del dot of epsilon naught into E, which is equal to rho V. So from this what I can say now, del dot of E, which is equal to what element of rho V by epsilon naught. We know that E is equal to minus del V. E is equal to minus del V. So that means if I place now here, so this is del dot of minus del V, which is equal to what element of rho V by epsilon naught. So will come it as what element of del square V, which is equal to minus rho V by epsilon naught. This is the Poisson's equation. This is called as a Poisson's equation. And if rho V, and we'll do this thing later. Next one, Laplace equation. अभी ने हमने देखा ना, Poisson's equation is what element of del square V, which is equal to minus rho V by epsilon naught. If rho V equal to 0, what happened to this equation? You tell me now here. Then del square V, which will becomes what element of 0. And this is called as a Laplace equation. This is called as a Laplace equation. Right. So you can see now here, the potential distribution is given as like this. The charge density they are asking to find. That is V. which is equal to 10 into y power 4 plus 20x cube. Charge density we need to find. So that is, we use the Poisson's equation. And what the Poisson's equation tell me now? Del square V, which is equal to minus rho V by epsilon naught. So this means first one time derivative, if I do it now here, dou by dou x of what, tell me now here, x derivative, so will come it as 60x square plus dou by dou y of y derivative, that is 40y cube, and which is equal to what, tell me now, minus rho V by epsilon naught. Again one more time differentiation. Will come it as what, tell me now, 120x plus 120y square, which is equal to minus rho V by epsilon naught. So the given the point is given as 2, 0. We put now here, this is what I mean, 240, which is equal to minus rho V by epsilon naught. So that means rho V is equal to minus 240 epsilon naught. So option D. Right. Next. So equipotential surface. What is an equipotential surface means what? So if the potential is same, then we can call that is an equipotential surface. So the locus of points in the space that have a same potential is called as a equipotential surface. So here if I join all the points in the space will have some potential. So if I taken some randomly, we have taken some points we have taken. So you assume that this potential, this potential, this potential all are same. Now join them. All these we have joined. If I join this thing, we have formed one plane we can form now. This is called as a equipotential surface. The locus of the points which are having the same potential, that space which we will call it as a equipotential surface. This is called as an equipotential surface. Okay, so the properties of equipotential surface. What the properties are? Equipotential surfaces. Equipotential surfaces. So here potential is same now. If I call this point is A and this point is B, if I call. Now you tell me now here. So to move the work done, how much you tell me now? Work done which is given as Q into, so delta V na potential difference, that is given as Q into, we can say that is VA minus VB. How much the potential you tell me now here? Which is equal to 0. So that means what is the work done in moving a charge in the equipotential surface is a 0. Work done is 0. So here no two equipotential surfaces cross each other, means they never intersect. Two equipotential surfaces never cross each other. And equipotential surface is perpendicular to the electric field lines. For electric field lines, equipotential surfaces are normal. The equipotential surface for the family of a concentric spheres is point charges, concentric spheres. For line charges, cylinders. Right. Now let's talk about the dipole. Electric dipole. Electric dipole means what? Tell me now here. if we have a two charges are there, let us consider this is minus q and this is the plus q. These two charges are separated by a very small distance. And so if I call this is O, the distance between them we used to call it as a 2L. And this is called as an electric dipole. And that for the dipole we can define the term called as a dipole moment. Dipole moment is given as what, tell me now here? Q into length. And so that this direction of the dipole moment is from the negative charge to the positive charge. P is a dipole moment will denote which is from the negative charge to the positive charge. Right. Next. Now let's see the electric field and potential for in case of dipole. Electric field. So for this electric field for in case of dipole which is given as Kp by Rq into 1 plus 3 cos squared theta. 3 cos squared theta. This is the potential electric field and potential which is given as that is Kp cos theta by R square. And where theta means what, tell me now? Here we have this is the negative charge and this is the positive charge. Now here these two separation distance is L and this point is midpoint, and here we have some point is there. This point is, let us call, to avoid the confusion I am taking it as M. So this distance from the point here, this distance is R and this angle is theta. Okay, then the potential at that point which is given as Kp cos theta by R square. Okay, now so if the point lies along the dipole axis, then we can call this as the axial line. Case 1, on the axial line, then theta value which is equal to 0. And here this is the dipole moment which is from negative charge to positive charge. Right, so in this case if I put the theta equal to 0, then how much will get this electric field, you tell me now? That is Kp, that is 2 Kp by Rq. And how much is potential, you tell me now here? That is Kp by R square. That is on the axial line. Now if they ask me a perpendicular bisector, that is called as equatorial line. So here on the equatorial line, so that means how much the theta value, tell me now here? Pi by 2. So what I will get this electric field now here, E value, which will come to be a what, tell me now? Kp by Rq, and potential V which will come to be a 0. On the equatorial line which is 0, axial line we have a Kp, so that is Kp by R square. Okay. Next we'll see the next one. Now see this problem. An electric field in a plane is described by its potential V given as like this. Now this electric field is due to what? Tell me now. That is given as 20 into 1 by R plus 1 by R square. So this electric field for in case of a for the single charge for monopole, potential is given for monopole. So potential is proportional to 1 by R. Electric field proportional to 1 by R square. Next, for dipole, potential proportional to 1 by R square and electric field proportional to 1 by R cube. Okay, now from this we can say now, and here there is their potential which is proportional to 1 by R square. So from this what I can say, here we have a monopole as well as a dipole, both are present. So now that means it is a combination of monopole and the dipole. Okay. Right. So this is the potential. Fine. Right. So with this topic has been completed. Fine. Next class will continue the remaining topic. Next we'll start this magnetic fields. Will start in the next class. Okay. Okay, then all of you do like and share to all your friends. And tomorrow also same timings will meet now 2 to 4.